All right, wonderful humans. So this is a video on the trends of the periodic table. So this is a breakdown that you guys can use to study, or if you're just really struggling to understand the trend, okay? So I'm going to go through this step by step. All right, so the first thing we got to understand is what trends are we trying to look at? All right, so first trend we look at Coulombic attraction, all right, isn't an individual trend, but it relates to everything. And that's the pull between your protons and your electrons, okay? Our next trend we look at ionization energy, okay? That's how much energy it's going to take to remove one valence electron, okay? Remember, the lower your ionization energy, the easier it is to steal an electron. All right? And then our other two that we're going to look at are electronegativity, the pull on a shared pair of electrons, and atomic radius. And atomic radius is the size from your nucleus to that outermost string, okay? And to understand these trends, you have to understand that they're all interconnected, okay? So let's start with the first one, all right? The first trend that we're going to look at, okay, is them overall. We're going to look at the relationship between all of them, all right? So we're going to first look at what happens if our atomic radius gets bigger, okay? So atomic radius affects a lot of things because it's going to affect how close your protons are to your electrons, okay? How close is your nucleus to that outermost ring, and what does that mean? So in this case, our atomic radius is going to increase, okay? So we have a bigger distance between our protons and electrons. If you have bigger space, the attraction, the pull between the two of them is going to decrease, okay? If the pull between the two of them decreases, it's going to make it easier to steal a shared electron, and the pull on those shared pairs is going to be weaker, okay? So attraction really results, okay? Whatever happens to the attraction, if the attraction decreases, ionization and electronegativity is going to decrease, okay? If attraction increases, ionization energy and electronegativity is going to also increase. So they're directly related. If one goes up, the other goes up, okay? So looking at the atomic radius, we can see how that going up decreases our attraction, which decreases our electronegativity and ionization energy, okay? So if we started with attraction, if our attraction is higher, okay, that means that our protons are closer to our electrons. So that means our atomic radius had to decrease, okay? Those protons had to be closer to those electrons because our attraction has increased, okay? If our attraction goes up, our ionization energy and our electronegativity goes up, okay? We can see the relationship between all of those. Atomic radius going down, increased attraction, which then increased ionization energy and electronegativity, okay? So to understand these trends, we also have to understand what they're doing on the periodic table, okay? So we first look at atomic radius because I personally think that's the easiest trend to understand, because it doesn't really you don't have to relate it to attraction unless you want to, okay? So the trend going down the periodic table increases, okay? So as you go down this group, they get bigger and bigger and bigger and bigger and bigger and bigger, okay? So the next thing we have to ask, why does that happen, okay? What is going on the periodic table that causes it to increase as you go down a group? Okay, and we should all be familiar with this explanation by now. It has more orbitals, okay? As you go down a group, an orbital is added, making that distance between our nucleus and our outermost shell bigger, okay? And that's all we're focusing on right now, is that distance between our nucleus and our outermost shell. So we're going to increase going down the periodic table because we add an orbital, okay? So that is our group trend, okay? But we also need to know our horizontal trend, okay? So going across the periodic table, all right, the trend for atomic radius is to decrease, okay? It's going to get smaller. Now this one we can't explain with orbitals because in a period, they all have the same orbital number, okay? So looking here, we got to ask ourselves again, why does atomic radius decrease horizontally? Can't be because of the orbitals. Right? It has to be another reason. And that reason for atomic radius is there are more protons and electrons going left on the periodic table, okay? So that causes the attraction to increase because you have more protons and more electrons interacting, and that causes the radius to decrease, okay? So again, the relationships we talked about in the beginning of the video are coming out again, okay? We talked about how if your attraction goes up, that means your radius went down, okay? So as we can see here, I picked two elements on the periodic table to look at. All right, lithium is the furthest to the left on the periodic table. Okay, it only has 3 protons, 3 electrons. As you move left, you go all the way to neon, which has 4 protons. It has 10 protons, 10 electrons. Okay, obviously, the more pull you have, the higher the attraction, the lower the radius. Okay, we may need to watch this more than once to fully understand that, but we need to understand that interconnecting relationship. All right. So on to our next trend, ionization energy. What is he doing as you go down the periodic table? It is decreasing, okay? And we should see the pattern that if our radius went up, okay, that means our attraction went down, which means that our other two are also going to go down. So ionization energy and electronegativity, all right? So why this happens has a similar explanation for ionization energy as it does for atomic radius, just in the reverse, okay? So as you go down the periodic table, we're going to have more orbitals. What that means is our radius gets bigger, meaning that our attraction gets smaller, okay? Which then means our ionization energy gets smaller, okay? So, again, that relationship, atomic radius goes up, attraction goes down, ionization energy goes down, okay? So if you just remember that atomic radius gets bigger because there are more orbitals, okay, then you know that attraction will get smaller, ionization energy will get smaller, electronegativity will get smaller, okay? So we looked at the trend vertically, now we're going to look at the trend horizontally. So the trend horizontally is to increase, which should make sense because the trend horizontally for atomic radius is to decrease, meaning it's the opposite. All right? So again, we got to ask ourselves why. All right, that's that 8.1 standard. All right, we learned from atomic radius that there are more protons than electrons as you move left across the periodic table. We used that lithium and neon example, okay? So what that means for us is if our atomic radius decreased, our attraction had to increase, meaning that our ionization energy also had to increase. Okay? So, again, all interconnecting. Your atomic radius decreases, your attraction increases, your ionization energy increases, your electronegativity increases. Okay? They're all interconnected. So for the next trend, electronegativity should be really easy because it's going to have the same reasoning as our ionization energy, and all of the trends are going to be the same, okay? So ionization energy decreases, electronegativity decreases because attraction decreased, atomic radius increased, okay? Atomic radius is the only one that is the opposite, okay? Because your protons and electrons are getting further apart if your radius is bigger. Okay, so again, we have to say the why. Going down, we have more orbitals, larger radius, less attraction, less electronegativity, and ionization energy. Okay, so again, more orbitals, our radius went up, everything else has to go down because our protons and electrons are further apart. Okay, so then for our final trend to understand horizontally, okay, it decreases because ionization energy, no, that's wrong. It increases, my apologies. All right, it increases, okay, because ionization energy also increases and attraction increases, meaning that our atomic radius had to decrease, okay? So why does it increase going horizontally? More protons, more electrons, more attraction, more electronegativity. Okay, and based off this, you could also know the trend for ionization energy and atomic radius. Because if electronegativity went up, attraction went up. That means ionization energy also went up. Then we have our oddball radius, which is going to be the opposite. So we don't know that radius went down. All right. Well, I hope this video helped. If we have any more questions, please let me know. All right. And have a wonderful time studying.